Alright, so before the break we went over these two routines quickly, the sort descending and the sort ascending. And these are real nice. Those are built-in C# routines. The first one, literally, this line right here says array.sort. You have to let it know that what the type is that you're going to sort, which are integers, and I want to sort the numbers array. And so that turns this into this. Does that make sense? Just sorts it in ascending order. Then when we're done, there's no descending order, so what I did was I took the ascending one that we had and I said, now reverse that order. So flip it. Alright? So that literally said, we said take what we had, sort it, and then flip it. And that put it in descending order. And then after we did that, I said just print out the results. Then for the ascending one, again, notice it's the same thing, but I can remove that line because I don't want the reverse line. But ideally, what you're seeing out of this is, I mean, look, 1, 2, 3, 4, 5, 6 lines of code in the whole darn module. This is a fairly well modularized program. Believe me, I'm not saying it because I wrote it. I'm saying it because it's fairly well modularized. There's more modules, but they're smaller, and each module is doing one job. That's the way that you're supposed to write code. All right. And again, a couple people asked, so that's down at the bottom. That's that thing I call just start array stuff, and I copied those lines. So I could put it up here for my sort ascending, so I could put it here for my sort descending, so I could put it here for the original order, and I don't know if I've got it anyplace else. Oh, there it is right there too in fill array. So now I can remove that from fill array, and I can call that start array stuff. So I've been able to reuse that same code in about 5 different places now. 4 lines of code, but instead of writing it 5 times, 4 times 5 is 20, it's now 4 lines with 5 calls to that. And I'll just check one more time to make sure. It says I've got errors, which is never good. Oh, I didn't put a semicolon at the end of something. Oh, that one. Ascending works, descending works, largest 96, smallest 1, good, average, good, sum, good, new numbers, and exit. So it's all done, and it's fully functional now. What's that? I can get rid of clear array and just call that one. You're right. Yeah, that was another thing Eric just mentioned, and he's right. That in here, now we've got this. We've also got this thing here someplace that calls the thing that calls fill array. We don't really even need fill array anymore. Or clear array. Down here, thank you. We don't need this anymore. Because what we can do down here is, if we need to, we can just say start array stuff. That'll do everything we want it to do. I'm taking this class online where this guy has built a website, and then he's doing a bunch of different stuff in it. He's using PHP and MySQL and jQuery and etc. And literally there are 134 lectures. I finished them last night. And the smallest one is 3 or 4 minutes, and the largest one is about a half an hour. So it's taken quite a while to go through it. But what he has done in the last 5 or 6 lectures is he just keeps tweaking his code. He's probably got about 500 or 600 lines, and he's cut it down by probably 10% each time he's done that. You get to a point you can't cut it down anymore, all right, or it becomes too hard to read, so you can't. All right. So chapter 7 in your book starts around page 389, and notice what's in here. Variable types and reference types, array basics, working with files and arrays, passing our arrays as arguments, array some useful array algorithms. I already went through some of those with you. Adding up the numbers in an array, getting the average of element in an array, getting the largest element in an array, and getting the smallest. There's a little bit of stuff in here on sorting and searching. Then two-dimensional arrays. And again, I've said this kind of thing before. You may or may not have heard me say it, but people tell me I can't work with multi-dimensional arrays. They're too hard. Isn't that a multi-dimensional array right there? Excel is a multi-dimension array. But whereas in Excel, you call that A1 for column A, row 1, in programming language, you call that cell 0, 0, row 0, column 0. All right. So we've talked a little bit before about value types and reference types, and call by value and pass by value. Virtually, other than, well, really, virtually everything we've done up till this point has been a value type. Stuff can only hold one value at a time. But now we're getting into reference types. We're talking more about things that are like data structures. All right? And that's what he talks about in here. He explains with that random ran and exactly what's happening in there. And I use that in the program. So if you didn't like my explanation or you didn't think it was good enough, notice what he mentions here on the bottom of page 391. It says the first part of the statement, that what appears on the left-hand side, says random rand. It declares a new variable named rand, and it's of type random. What appears on the right says we want to create or instantiate or create an instance of the random class, and when we get done, we're going to point to it. The pointer for it is going to be called rand. And that's exactly what he explains in here. All right, then he gets into array basics, and again, I've done this in the lecture. But if you'd imagine, and I didn't put this part in the lecture, but I'll just put this because I've explained it like this before. So imagine that you lived in an apartment complex, all right? And we're going to keep it real small. There's 4 families living in there, all right? There's the Scott family. There's the Jones family. There's the Black family. And there's the Green family, all right? And it just so happens that this is at 123 Main Street. So you know as well as I do that if I get something, it'll look something like Jeff Scott, 123 Main Street, apartment 1, something like that. All right. We do a similar thing when we're working with arrays. All right. So what's different? Well, first of all, this wouldn't end up being apartment 1, it would be apartment 0. And second, since these are strings, we have to make sure that when we're declaring these, we put them all in double quotes. But if I want to create an array, whoops, and I'll just call it apartment, okay? And it's going to hold strings, I say string, bracket, bracket, apartment, equals, now I can say new string, yeah, I can do that, but I don't want to do that. I've already got my values. So I can put in curly braces here all this stuff. So I can go in there and do that. That says I've got a string array. And that string array has 4 elements in it. Element 0, doing this line right here, this line, saves me from having to type it in 4 times. So I could have said otherwise, I could have said apartment 0 equals Scott. Apartment 1 equals Jones. Apartment 2 equals Black. And finally, apartment 3 equals Green. Does that make sense to people, what we just did? An array is actually, it's a set of contiguous memory locations, one after the other in memory. And in this language and in Java, an array has to hold the same type of data. You may or may not remember this, those of you who were in the JavaScript class last semester, but you can make a JavaScript array and it can hold numbers and letters and booleans and all sorts of stuff. You can't do that in this language. This can only hold strings. If I try to come in here and add something else, if I say apartment 4 equals 127, I'm going to get an error message because I'm trying to put a non-string value. If I wanted to do that, I'd have to put it in double quotes. Same kind of thing. I couldn't say that that's equal to true. I'd get an error message. No. Well, could you do it within images? Yeah, but again, they'd have to be in double quotes. If you were putting a URL or something like that in there, yes, you could do that. All right. But you can create arrays of anything. So I could say int, bracket, bracket, grades. And let's assume that there were 10 of you in here. All right, I'm just making these up. Six, seven, eight. Again, I could write it like that, or I could do it like this, where I'd say grades, bracket, bracket, 0 equals. Since these are numbers, we cannot put those into double quotes. So you could have an array of anything. Now, arrays in C# and arrays in both C# and in Java, both those kind of arrays, they're known as being early binded. And what that means is when you compile the program, it has to set up the size for the array, how many elements or how many things it's going to contain. All right, why am I telling you that? Because last semester, what we looked at with JavaScript and what we look at next semester with PHP is those are late binded. And when they're late binded, they're done at runtime, which means that you can change the size of the array when the program's running. You cannot change the size of an array once you declare it in Java or in C#. But you can create something called an array list. You go, I don't know what those are. And believe it or not, you sort of do, just because you start using that weird looking syntax when you work with lists. All right, so he goes over array basics I just did with you. Okay, the things that are in an array are typically called elements or subscripts. And just so you know, because you'll hear this again and again, the way that you would read this right here is apartment sub 0 equals Scott, which means take the value Scott or the string Scott and assign it to the first location in the array called apartment. This would say right here, take 45 and assign it to the first location in grades. Once you start working with arrays and you start doing something, let's just say like this. Those are just individual variables that have been stuffed into a super variable, for lack of better words. So if you're dealing with just one of these, it's just a variable. When you're dealing with the whole thing, it's a collection of variables. All right, and he talks about that a lot here. Again, like I said, I've already gone through and done the lecture, and a lot of the stuff I'm just repeating that you've already heard, or you'll see it when you watch that. There's the initialization that I showed you already. Arrays are meant to work with loops. They literally work hand in hand with one another. So this, I've created an array of size 3, and now I'm saying go through that array and set every value that's in there to 99. I don't know, why would you want to do that? I don't know. But if we wanted to set them all to 0, And hopefully when you see this, this is where you'll start to see, oh, that's why an array would be a cool thing. Because if I go through there and I'm writing some code and I write this, let's just say that I've got something, I've got a constant that says num students, and it's equal to 50. And I've got some code in here, I don't care what it is. But I'll say for int I equals 0, I less than num students, I plus plus. Now in here I do a bunch of stuff. So I've got an array and I've got some other stuff. I don't care what it is. But the point is, now I get another class. And now I've got 75 students. All I have to do is change that. And I can work with all 75 or 50 or whatever students right inside of the same routine, rather than writing it 75 times, which is just asinine. Right? So that's what he explains in here. Now, one thing you can't do, if you don't look on the screen here, maybe somebody can answer this question for me. What if I did this? What's wrong with that? No. Good guess, but no. What's that going up to now? No. What's it going up to now? 50. So now it's going to count 51 times. If I count from 0 to 50 and include 0, that's 51 values. That's called an off by 1 error. And it won't put you into an illegal loop, but what it will do is it'll say something like an invalid array exception. Something like that. That'll be thrown. Not a good thing. That length property I already showed you. That just says how many elements are in the array. Let the system do work for you when you can, as opposed to you doing the work. You shouldn't have to count how many elements are in an array. And I'll tell you this, and you might be offended. It's not meant to offend you. But if I let you count how many numbers are in an array, or me, we might screw up. But if we let the system do it for us, it shouldn't screw up. Now, is it possible? Sure, anything's possible. But it shouldn't happen. On 401, there's a shortcut, another way that you can write a for loop, and it's called a for each loop. It looks like this. You go, wait a minute, why don't we write in that one? There's less to write. Yeah, but you can only do it for certain things. So they show you an example here if you want to print out all the values that are in an array. That looks a lot nicer than a for loop. It's a lot more concise. But if you're going to change anything inside of the loop, you can't use a for each. You must use a regular for. So I'll let you read that. They explain that right here. All right. Now, one thing I can't do, just so you know, all right, I'm going to go to about 9:45, so if somebody can stop me when it gets to there, we'll just be done. One thing I cannot do is I can't do this. I can't do this. Int grades equal this, and then on the next line say int bracket bracket grades 2 equal grades. I don't get an error message when I do that. I don't get an error message. But what happens is this is now an alias. They now both point to the same thing in memory. If I want to go and copy everything that's in here to in here, I've got to put it in a loop and copy it one element at a time. All right? And that's what they explain in here. And they even tell you that if you try to do that, you're going to be surprised. Read this section that starts on page 404, working with arrays and files. Oh, files, ugh. Yeah, it's like 4 pages long. Because the input that you use for the program for Chapter 7 comes from a file. Okay? If you follow the steps they have in that program, you'll be fine. You can pass an entire array into a method. But if you pass it in, you've got to do something like this. You're used to saying stuff like string and then the variable, but you got to say bracket bracket if it's an array. That's the only way that the system knows that it's an array you're passing in. I'll let you read this section. If you want to make permanent changes, you can use either the word ref that we talked about in an earlier chapter or the word out. You shouldn't even have to worry about that for your assignment. I don't think I used ref or out. I'll go back and double check, but I don't believe I did. Now, some useful algorithms here on page 414. These should look familiar. All right, the first one isn't. It's a sequential search. So if I said this, going back to the example that we looked at, before, this one. Come on, where are you? If I said to you, is the number 37 in there? You're all smart enough that you could scan the list, okay, and if it was in there, you'd say yes. If it wasn't, you'd say no. Computers aren't as smart as you are, so you got to start at the top of the list, and ideally, you're asked for 45, okay? But no, so 37. No. It's not there, okay? And you say, well, it's kind of like looking for a name in a phone book. It is, but imagine you're looking for a name in the phone book, and the phone book's not alphabetized. All right, now you go through the whole phone book just to find out the person has an unlisted number. That's kind of like what we just did here. All right, so with a sequential search algorithm, which is what they talk about first, it's very slow, but it's very complete. And a lot of times, if something isn't found, you just return -1, and -1 typically means it's not there. Copying an array I already mentioned to you. Same thing when you compare an array. You've got to compare it an element at a time. You can't just sit there and say, is this one equal to this one? You got to compare each element that's in there. Sound familiar? Totaling values in an array, does that look familiar? We use sum plus equals. All right. Averaging. The sum divided by the length. Same kind of way we did it. Finding the lowest and the highest. Again, we're just going to assume in here that the lowest or the highest is the first one. And the reason that you assume this is now you don't have to check that one. You only have to check 4 of them as opposed to checking 5 of them. A little faster. Again, the lowest and the highest are exactly identical. You can have partially filled arrays in here. What does that mean? That means I can create an array and not know ahead of time exactly how many values it's going to have in there. It's a fairly complex topic. We don't need to worry about it. We're not doing anything with partially filled arrays. Finish this, and then regardless of the time, then we will be done. Finally they talk in here a little bit about searching for things. When you search for something, what you search for may be in order, and it may not be in order. All right, with a selection sort, if you look up on the screen here and you look at this picture, you go through here and you go through every element and you find the smallest one. That's a 1, right? So you flip it with whatever is there. So I'd flip the 1 and the 5. So now I'll go through again, but now I know that one's there, so I don't have to check this one anymore. So I have to start here. And with just a matter of flipping things. That's one way of doing it. Again, it's very slow. Another way to do it, and they talk about this next, is what's called a binary search. And again, I go through a lot of detail on this. It starts on 434 in the book. And that's what I refer to as a halving, H-A-L-V-I-N-G. You get a list of values. So again, think about the example that we looked at before. Now I want to know if 37 is in there. But it's already in sorted order. So I go halfway into my array, right there. Is it 37? No. Is it higher or lower? Okay, it's lower. So all these are now out. So I cut it in half again, which puts me about here. Is that the number? No. Is it higher or lower? So now in 2 guesses, I've removed all of these, and I've removed all of these. So as I keep cutting it in half and in half, all right, it gets smaller and smaller. That's a very fast sort. All right, and that one is explained in there. And then they talk about 2-dimensional arrays. We're not going to worry about them because we're not going to use them. They talk about jagged arrays that we're not going to use. And the only other thing that's mentioned in here, and this is important, so please read this, is on 446 till the end of the chapter, about 5 or 6 pages. And that's the list collection. That we're not going to go deal with it this semester, but you'll deal with it next semester in other classes. So it's important that you read that. All right? Last thing, because I'm finished, but so now from chapter 7, you've got to finish this ArrayFun program. Technically it's assigned today, but notice how much time you get. You get till 3 weeks from Wednesday. The 23rd is when it's due. The other one that you'll do is this U.S. population one, and that's on page 463. Do at the same time. Next week will be lab. If you do come in Wednesday, you've got 3 days of lab. All right, then 2 weeks from now, which is the 13th, Monday the 13th, I'm going to go over chapter 8 in one class period. All right, and then the next class was going to be a lab, if we can do it in one class period. Then the last 3 weeks of class, we're going to go over chapters 9, 10, and 11. And the way I'm going to explain it to them to you is you're not going to have to type anything. I'm just going to give you hard copies of code. And we're going to go over the stuff that's in there. That's the way that we'll finish the class up. Questions? All right, because that's all that I had.